Hi, welcome to another video of my series of Waec exam solutions. Here we have the ninth question of the 2013 exam, and we basically have to simplify the given algebraic expression. For this problem, you're going to need to be able to divide and multiply fractions and spot a few things. First of all, you need to be able to spot that this is a difference of two squares. As you can see, you have x squared and y squared. So you have two numbers squared and you're subtracting one from the other. That is a difference of two squares expression. And here also there's room to factorize this expression. I'll show you. So let's proceed. First of all, just a reminder of the difference of two squares. If you have an expression of the form a squared minus b squared, where a is a number or variable detailed for b, you can rewrite it as a minus b into a times a plus b. So that's one thing you need to know. So therefore, the x squared minus y squared term in the given expression can be written as x minus y times x plus y. Looking at the expression as well, 3x plus 3y can be factorized. If you consider the fact that 3x, in terms of its prime numbers, and in terms of a product of prime numbers and like variables, can be written as 3 times x, and 3y, similarly, can be written as 3 times y. You can see that these two terms share 3 as a common factor. Therefore, using 3, the technique for factorization, an easy technique would be to just say, well, 3 is a common factor, so I'm going to write 3 first. I'm going to have the original term in a bracket, and then I'm going to divide it by the common factor. That's a technique for factorizing. And what one will do is simplify the term in the bracket. So 3 in, some people might not know what I'm doing. But, you could, you can cancel the 3's because that is how you'll carry out algebraic division. For people that don't understand the technique, I'll explain another way. But this is what you get from factorizing. So let me just clarify the division. Now, the division within the bracket was 3x over 3y divided by 3. And you can rewrite this expression as 3x over 3 plus 3y over 3. So simplifying each fraction, 3 here, 3 here. Wow, what was that? 3 here, 3 here, 1, 3 here. What did I say? Sorry, 3 and 3 is 1. 3 and 3 is 1. So you have x plus y left. So that is another way to do the division, and you get the same thing, x plus y in the bracket, which is what we had or have here. So now I've simplified the highlighted terms, the x squared minus y squared term, and the 3x plus 3y term. I factorized that, and that's going to aid the simplification. The reason why we did that was breaking down terms into like the factorized form or the expanded form in the case of different two squares is always a useful technique when simplifying problems. So that's good to note. Something that comes from experience. So you just try things like that and it breaks things down. You see how it becomes useful. But I just want to emphasize the technique for division. If you have a term with, however number of numerators and with just one denominator, you can express it as each numerator divided by the common denominator, and you just keep the signs. So a plus b plus c all divided by x is a over x plus b over x plus c over x. Similarly, a minus b over x would be a over x minus b over x. Also, if I had minus a plus b minus c over x, it will be minus a over x plus b over x minus c over x. So really is just a way of simplifying problems, and that's exactly what I did for the term in this fraction here. This was 3x plus 3y over 3. So what you do is rewrite 3x plus 3y over 3 using the technique I just showed you as 3x over 3 plus 3y over 3. Again, as you can see, each numerator term is picked and divided by the denominator, and the signs are maintained. And it's as easy as that. And then you carry out a division of each fraction and simplify, and get this x plus y, which is what I chucked, which is what this whole division here gave, x plus y. Anyway, I just thought I'll show you that before I actually solve the problem. So I'm gonna clear the sheet, and then we're gonna start afresh. So we have x squared minus y squared equals x minus y into x plus y, and we also have 3x plus 3y equals to 3x plus y from the factorization I showed you. Therefore, the original expression can be written as, instead of x squared minus y squared, we have, okay, let me write the whole thing now and show you what is changing, because this can be confusing. I think another thing I like to do is, instead of dealing with a division problem, it's always easier to rewrite it as a multiplication problem. So I'm going to have the above expression here go into x squared minus y squared divided by x plus y all squared times the reciprocal of this term, which means I just swap the position of the denominator and the numerator. That's what you do when you change when you have a situation where you're changing the division sign to multiplication sign. You just take the reciprocal of the term following, or the expression following the division sign. You take the reciprocal, which simply means swap the position of the denominator and the numerator, which is done here. Here, x minus y squared is the numerator. Here, it's the denominator. Here, 3x plus 3y is the denominator. Now, it's the numerator. So now that we have this, I can now say, well, using the differences two squares expansion I showed you above and the factorization, I have this now. So x squared minus y squared has become this. The x plus y squared stays. The 3x plus 3y becomes this, and x minus y squared also stays. So we have, if I multiply the numerators together, I get I'll keep the 3 here. X minus y squared. Now I'm gonna group, this is equal to, I'm gonna group some terms. So notice that we have x plus y here. I have x plus y here. So I'm gonna group them together and multiply them together so we can have a simpler form. So x minus y, I'm gonna bring the 3, because all of this just simply means multiply each term by each other. And when you have an expression that solely involves multiplication, because here there's basically an invisible multiplication sign, an invisible multiplication sign, an invisible multiplication sign. When you have an expression which simply involves the multiplication of all the terms, it doesn't matter the order, or rather the order in which you carry out the multiplication doesn't matter. So I can bring 3 in front and say, oh, 3 times x minus y times x plus y times x plus y. And here, I can do whatever I want. For the denominator, I can keep it the same, or I can change the order in which you carry out the multiplication. It doesn't matter. Anyway, this gives x plus y squared. So I'm just going to rewrite that here. Because x plus y times x plus y. I mean, think about it. If you had a times a, you would have you get a squared. 2 times 2 is 2 squared. So x plus y times x plus y is x plus y squared. Denominator is still the same. So now this is the expression we have. If you look at the numerator and denominator, you see that we have x plus y squared here and x plus y squared here. So you can divide x plus y squared by x plus y squared, or as some other people say, just cancel them out. I mean, it's one thing to do. I mean, this would be 1, but I mean, it's basically saying how many times can x plus y squared go in x plus y squared. And any number divided by any term or number divided by itself it's 1. So that simply goes, and we have 3 into x plus y over x minus y squared. Now, finally, I'm just going to introduce an important law an important exponent law. I think they're also called the laws of indices. We're going to point out one in particular, which is useful. If you had a term, you have this, right? X over n divided over x to the m. So sorry, x to the n divided by x to the m. You rewrite it according to the laws of indices, x to the n minus m. You should be familiar with all of those laws. This is what I'm going to apply here. In this case, we have, you can think of this expression as 3 times x minus y over x minus y squared. As you can see, it's of this form. It's, you can think of this as 1, x minus y to the 1. Because anything raised to the power 1 is itself. So we applying the law, we'll have x minus y to the 1 minus 2. Just simply following this. You get 3 times x plus y to the 1 minus 2 is minus 1. So we have 3 into x minus y to the minus 1, which is the same thing as 3 over x minus y. Another important law important exponent law is the one that goes as this: 1 over x to the n is x to the minus n. So if you had say you started from x to the minus n, you can write it as 1 over x to the n. So say you had 1 over 2 to the m3, you can rewrite it as 2 to the minus 3. It's the same thing here. X minus y to the minus 1. So let me just show you this here. X minus y to the minus 1 is the same thing as 1 over x minus y to the 1, which is the same thing as 1 over x minus y. So you're basically treating x minus y as x here, because x here just represents a variable, and x minus y is a variable. So you treat the whole bracketed term x minus y as one thing. That's really what it is. From here, we could have just cancelled out this x minus y with that 2. Some people will understand it, but some people might not. That's why I didn't want to do it that way. Or another way you could have done the simplification is rewrite the expression as 3 times x minus y over x minus y squared is what? X minus y into x minus y. So you just cancel out x minus y, and all you're left with is 3 over x minus y. So there are many ways to simplify the problem, but just going over it, the important things are to spot that there's a difference of 2 squares expression, which can be expanded to give this, and there's also room for factorization here. And if you see, by rewriting 3x plus 3y as 3 times x plus y, we were able, if you just see here, where did we actually carry out the cancellation? We were able to group the x plus y terms to give us x plus y squared, and able to cancel x plus y squared and x plus y squared here, which made the problem simpler, made it involve less terms. I mean, simplification always has to do with cancelling out terms that can be cancelled out, basically reducing the complexity of any expression. I mean, look at what we started with. We started with this nasty expression here, and look at this. It has like 4 terms, and I mean 4, well, whichever way you want to count it, and we ended up with this simple 3 over x minus y. So as you can see, we have simplified the problem, and that is your answer. So there you go. Thank you for your time, and if you have any questions, leave a comment, and if you like what I'm doing, hit like on the Google page, and spread the word. Thank you.